Ceramo power is a combustion promotion system utilizing titanium oxide and a ceramic matrix to boost engine combustion performance to close to 100%. Ceramo power fragments the oxygen cluster ions in the atmosphere using electrical charges emitted by the substrate. The cluster ions, which have prevented complete combustion in the past, are broken down into oxygen molecules, which disperse easily. When fuel is injected, the combustion rate is significantly improved. Fuel is combusted completely and without waste. This is Ceramo power. More power, reduced environmental impact, better fuel economy. Ceramo power has been patented in Japan, America, and Europe. Take a closer look at the performance of Ceramo power. A survey of Ceramo power users showed that 40.7% of them plan to use Ceramo power in their next car, too. Combined with customers who felt happy that they had installed Ceramo power, a total of about 78% of respondents expressed satisfaction. The performance of Ceramo power has been verified through a range of experiments by public agencies both in Japan and overseas. In addition to user merits like better fuel economy and higher power, Ceramo power has also been shown to provide significant reductions in carbon monoxide, hydrocarbons, and nitrogen oxides. Just what principles make it possible for Ceramo power to improve combustion efficiency? The theory has not yet been completely verified, but our engineers believe that the effect is due to an interaction between oxygen cluster ions in the atmosphere, titanium oxide, and ceramic discharge. Exactly what are oxygen cluster ions? An oxygen cluster ion is a group of 10 to 60 oxygen molecules. These clusters are created in the atmosphere when ultraviolet radiation from the sun irradiates oxygen molecules. They were discovered by Professor Alexander Chihevsky of the Air Ionization Laboratory in Moscow in 1934. It is well known that air is a mixture of a variety of molecules, including oxygen, nitrogen, and carbon dioxide. Of these, the one with a direct relationship to combustion is oxygen. Atmospheric oxygen normally appears in a stable molecule, consisting of a pair of oxygen atoms. Let's take a closer look at these oxygen atoms. If we magnify the atom and look inside, we find the nucleus. The oxygen atomic nucleus has 8 pairs of protons and neutrons. Protons are particles with plus charges, and neutrons are particles without any charge. The nucleus is formed of 8 proton-neutron pairs, giving it a net charge of plus 8. Now take a look at the whole atom. There are 8 electrons in orbit around the nucleus, 2 in the inner shell and 6 in the outer. This is the same as the number of protons in the nucleus, which means the atom is in an electrically balanced state. The oxygen atom, however, is not always stable by itself. It is only stable when the outer shell has 8 electrons. In other words, it requires 2 additional electrons to achieve stability by itself. This may cause the outer shell to steal 2 electrons from somewhere else, turning it into an oxygen ion, or achieve stability by becoming an oxygen molecule, the most orthodox state in the atmosphere and perfect for combustion. In this state, the oxygen atoms achieve stability by sharing electrons through covalent bonding. Another stable state is the cluster ion. When an electron is accepted into the outer shell of an atom, there are times when it can cause clusters of atoms, grouped in a random order like a cluster of grapes, due to factors such as covalent bonding. The cluster ion is extremely unstable because covalent bonds often change. In addition to oxygen molecules, oxygen cluster ions are also present in the atmosphere. Cluster ions are not needed for complete combustion, however. Our engineers believe that combustion efficiency is improved because the cluster ions are fragmented by the discharge effect from the substrate. Oxygen molecules are formed from the fragmented cluster, contributing to complete combustion. Ceramo power, delivering high-performance air for your engine.